Hello guys, in this video I would like to explain about Durbin-Watson test in R and RStudio, and we have already done this test in Python, and of course I'm doing the videos in Python and R in such a way that I explain methodology, the theory, and the reasons why we need a particular test, a particular method, and then I implement those methods or models or tests in software like R RStudio and Python. So I have explained the theory behind this test in the previous video in Python, Durbin-Watson test in Python. And if you want to see that, if you want to watch that, link to that video is given in the description of this video. However, I will just briefly explain that what is Durbin-Watson test and why we need it. There is one assumption in the regression analysis that the data or the residual should be independently and identically distributed. So this means that there should be no correlation, autocorrelation or serial correlation. For that purpose, there may be other tests as well, but the Durbin-Watson test is one of the best tests you can use to see whether there is autocorrelation or serial correlation in the data in the residual or not. But remember that you can use this for any data to see the autocorrelation in the data. It's not only developed for the residual of the regression model. So you can use for any other when you need to see whether the data there is autocorrelation or serial correlation in the data or not. You can use this test. There is no issue. And you can use this to the multiple regression and simple linear regression, etc., to see whether the residual has autocorrelation or serial correlation or not. So in that context, we will do this, explain this today in R and RStudio, and you can see that you can see in the front, in the middle of this this slide, there no autocorrelation mean in the D statistic, the value of the Durbin-Watson DW statistic is close to 2 or exactly 2 or in this range. And if it is on the left side, I mean that this is close to 0, this means that positive autocorrelation. And if it is on the right side, on this side near to 4, this means that negative autocorrelation. So remember these things, and today we will see the p-value and the statistics, so that will be easy for us to decide whether uh, we will accept no autocorrelation or reject no autocorrelation. And remember one thing more, that is the null hypothesis in the Durbin-Watson test is there is no autocorrelation in the data. And of course, the alternative hypothesis should be that there is autocorrelation in the data. So this means that if the null hypothesis states that there is no autocorrelation in the data and the p-value is greater than 0.05, this means that we accept the null hypothesis and conclude that there is no autocorrelation in the data at 5% level of significance. Remember. So this is all about the background, the use, and what is the Durbin-Watson test. Now let's move to RStudio to see how we can do this in RStudio for our research. Okay, we need to install this package, car, and I already installed, so I don't need this. Just you need to use this command, install dot packages and bracket, double commas, and core. And this now you need to call core. Yes, working is installed. I need to just generate some data, but of course you should have your own data, real life data for regression model, or just not only for regression model, maybe other purpose. So I'm just generating this data, and remember that I'm just using this for the residuals, but you can use for your data like X data, Y data, and this, so no problem. And so just to see whether data has autocorrelation or not. Yes, okay, so that's it, just for the reproducibility, and X is random norm, 100 values, and now this is Y is constructed in this way to multiply by the independent variable X plus R norm 100. You can plot these two variables like just scatter plot of X and Y. So this is the regression model. You can see the relationship is obvious. Yeah, y is dependent variable and x is independent variable, and so there is a relationship. The relationship, the regression parameter, the regression parameter, slope parameter, that should have positive value, and yeah, in this direction it is increasing. So you can draw some inferences about the data as well. Just by the way, just on the way, not by the way, just on the way to Durbin-Watson test. So you can see some things about the data, what is the behavior of the data. Okay, so you can write here just to see plot if you want x and y. This command is very useful command. This, yeah, it's going to give you something like this. And if you want to use some color by your choice, COL, that's obviously I will definitely use blue color, one of my favorite colors. Yeah, that's look like this. So you can see. Okay, so let's go to the main. Okay, so I just want to show you that the null hypothesis in this test is there is no first order autocorrelation in the residual, and there is first order autocorrelation in the residual. So I mean that there is there as the null hypothesis is important. Remember that. Okay, so now this should be not here. This should be here. Yes, yes. So now fit a linear model. We have already done simple linear regression and multiple linear regression and Python and R. So if you want to see the links to those videos given in the description, so you can go and click and see what is meant by linear regression, what is meant by regression, multiple, simple, and how we can do. So there are lengthy videos you can see and you can learn many things. So this means linear model, LM linear model, and function y is running on the x. X is independent variable, y is dependent variable, and the result is stored in model. So just run this, and you can write model, and then you will see. Yeah, this is the whole thing. This is the model, the formula. Okay, y is regress on this. Y is equal to alpha plus beta x. So you can see that this is the intercept is minus 0.108. And I already told you that it will look like this. Just plot this again. Yes, so I already told you that the coefficient of the x should have positive sign, and the value is look like this. So I was unable to guess the value. It's not easy. So this is the value and positive because there is an increasing relationship as the x increasing, y increasing. So okay, now you apply Durbin-Watson test to the model. The fitted model, this one. So this is the syntax, Durbin-Watson test. And remember, you need to be very careful that this T is capital test. So just apply this Durbin-Watson test. This is the function from R, and apply on this model, which you already fit here. And result will be stored in DW underscore test. So then you can see the result from DW underscore test. Just run this. Yeah, it's working, and now you can print DW underscore test and you will see the results. Okay, so the DW statistic is 2.23, and remember that I already explained this. If it is near to 2, this means that there is no autocorrelation in the data, and you can see now this is close to 2.23, so we can say there is no autocorrelation. But if you look at the p-value, that's confirm this claim. The p-value is 0.264, which is far higher than 0.05. So this means that there is no autocorrelation for sure. So you can see, you can decide like this if you look this, but mathematical results confirm this because they have specific values to 0.264, and you know the null hypothesis there is no autocorrelation. So the p-value is greater than 0.05. We accept the null hypothesis and say that there is no autocorrelation in the model which we have fitted. And as I told you, you must be aware about, the small and capital letters. So like this, T is capital, just press upper arrow key, you will see this, and just make it small. small t, not working. This is very, this is very sensitive. R is very sensitive to this. So it's not working. So you must be very, very, aware about these things. So I think this is all about, you can use this Durbin-Watson test like to just try to use this for X. And now here DWX, just name it X. Now you can see the results and just, okay, so this is something like, oh, I need to use this. I'm just using the other data, the independent variable. Okay, so this is 2.01, so it's very close to close to 2, so there is no autocorrelation. So it's not necessary you are using this test to the residual of the model. You can use this to any other data as well. Like we can use this to now the dependent variable y. Okay, like this is my dependent variable, and I will just write it's this y for easy. Okay, no, yes, that was wrong actually. This should be capital. Yes, test is capital. So I'm just testing now the dependent variable. This is also close to 2.02. So this means that there is not a correlation. So you can use to the other data as well. If you have data, for some purpose, you want to know whether there is autocorrelation in the data or not. So you can use, very simple to use. So I think it's enough for today. What we have learned today, I will summarize. We just learned about Durbin-Watson test. What is Durbin-Watson test? For what purpose we are using this? Why we need this test? And then in or we have generated data, then apply the test, and then interpret the results. And we also explain where we can use this test rather than regression models. So this is all about Durbin-Watson test in R RStudio. So if you like the content, please share with your colleagues, your friends, so that they can learn something for their research easily. And write me in the comment box if you have any question or you want to know some things which I need to explain. Thank you very much and see you in the next video. Ciao.